Assalamu alaikum and hello everyone. How are you? Let me just share you my screen. Okay. Yeah. So I welcome you all in this webinar. The topic that I'll be going to discuss is securing blockchain from cyber threats and exploration of use case. And before I go with this, let me tell you something about the logistics. So the screen, the video of you all will be off. And also there will be your mics will also be off as we are, complying with the regulatory things. And also, if you have any questions during the middle of the session or anything in which you want to have more clarification or something is not clear, there is a Q&A tab over here in your Zoom console, in which you can write down, and during the end of this presentation I'll be happy to discuss everything with you, and then you can write your notes if you want to have it. So it's a good thing that we can be able to we can be able to discuss in the end. Okay, so yeah, now yeah, coming back to the topic, why I choose this topic, because I think that in mostly once we are talking about emerging technologies, especially blockchain, there's not much enough attention that is being given to this, or given to the security concept, and security is always considered an afterthought. Once something happened or once we experience an hack or attack or something, or some penalty from the regulatory bodies, then we take care of all our things. We make sure that we are following the process and everything is right. So with emerging technologies, blockchain is very much in ours, and especially in Saudi Arabia. So we need to be sure that once we are building an application like blockchain or any solution with this, security should be job zero for us. Like, we need to design our solution by considering security as a foremost point. And because if we are having any hacks, we can lose $1 million. So that's very important thing. Coming back to this, okay, agenda, what we'll be going to discuss. Okay, as I told, or as I mentioned previously in my discussion, that we all know what blockchain is. I will not be talking much about the fundamentals and these things, but I'll be talking everything from the security standpoint. So what we'll be going to discuss will be I'll be giving you the fundamentals about, okay, like setting the stage, like when it comes to blockchain from the security standpoint, what should be considered or what should be our focal point. And then okay, there are some concerns over GDPR also, that some says blockchain is complying with GDPR, some says it's not. So we'll be also highlighting this part, that how you can have a GDPR compliant solution within the blockchain space. Then I'll be discussing different vulnerabilities, security basics. I'll be highlighting the top 5 attacks on blockchain, that what are those attacks, how those attacks can be mitigated, and and how we can secure our platform from those attacks. And then I'll be discussing about the decentralization aspect of blockchain. Like, we say that blockchain is decentralized, but what are the different components that once we'll be going to build an infrastructure, so once we are talking about blockchain, is it completely decentralized or some part of that is decentralized? So we'll be highlighting that point. And then I'll be going through different data flow and threat modeling techniques. We'll be discussing security domains, and how you can once you're building a blockchain solution, what sort of different components that can be in your governance framework, or what sort of mitigation strategies that you can place. So it will be a fun filled session. And I actually highly encourage you to take the notes in between the slides, so that we can take all those questions and any confusion in the Q&A section. Okay, moving on, just a bit about introduction about me. As most of the people know me already, I'm working in Huawei as their technical director. I'm also associated with some local and international firms as their advisor. And I'm also being proud that I was the first one as a blockchain Saudi trainer. which is from the USA body. And I recently developed an application which is for the Saudi market, which I'll be discussing at the end of the presentation. So that's all about me. You can approach me on LinkedIn or or WhatsApp or whatever feels right for you. Okay, so what are the fundamental and GDPR concerns? Okay, so security for blockchain is directly related to the security of other system it is integrated with. Let's say that if you are building a use case for a payment application, or let's say for a supply chain use case. So you'll not be building, so as you know that blockchain is just a database, but how about if you want to connect your nodes with one router? Or what if you want to integrate your blockchain solution with some exchange? Or, and what about the users that you will be, having it, how they're accessing your system? So, so there are different components involved once you want to build a blockchain, a use case or a blockchain solution, So blockchain security is directly related to the security of those components also. So what I mean is that once we are building blockchain, like an enterprise blockchain, so any entity that is a part of ecosystem needs to be taken care of and given equal importance. Okay, so we cannot say that if blockchain, let's say, is storing the data effectively using cryptography, so it means that other entity will be also doing the same practice or having the same security measures. So that's the thing, that once we're talking about blockchain, it's decentralized only for the part which is storing the data. Okay, like for the data flow that is been going inside the ecosystem, it can be decentralized or it cannot be decentralized. So there is a thing which we need to take care of. Then the second point of the discussion is that there's a polarized debate happening that once we're talking about GDPR. Okay, first, just tell me or let me tell you about what GDPR is. Maybe some of you know or some of you don't know. So if GDPR, what we mean is that how we are protecting the personal identifiable information of our users or our customers. Whoever is a part of whoever is a part of our ecosystem, whether are we saving the personal identifiable information or not. Okay, and if I'm saving that information, okay, that information needs to be processed in a certain way. Or if I'm operating in, let's say, EU or European Union, okay, I need to have certain GDPR laws which I need to comply. Let's say that what sort of information that I can save of my customers, okay, for the data addressed, what I have to comply with this, in order to make sure that if my data is being hacked, whether it's in the encrypted form, so there are a lot of things related to the GDPR. And if we are not GDPR compliance, let's say, so we can lose our revenue around 4 to 5% on an annual basis. So you can imagine that how much critical is that. And okay, and also if we need to scale blockchain and talking about with regulators, we need to make sure that once we are talking to them, we'll be in a position to defend our solution from the GDPR perspective. So that's how much important it is. So within the blockchain space, we know that it's been, we are using cryptography, using a private key to sign the transactions, and it's in the encrypted form, But how about if we are saving the data of our customers, of our KYC data of our customers in blockchain? Okay, so it's not a good idea, So how blockchain can be GDPR compliant is that if we are not storing the personal data in the blockchain network, we are storing that on an off-chain database. Okay, that's one. Second point is that we can be able to control who is accessing our network. Like we can be able to some sort of role-based access control, in which that we know that what sort of access rights we need to give to that party to do some operation on that data, whether he is privileged or whether he's authorized to do that thing or not. So we have to put some sort of rule-based access control or role-based access control. Okay, then if let's say if somebody needs to prove the identity, okay, we can have something like zero knowledge proof, in which the party don't needs to disclose the information. He can do this by some sort of identifiers. He doesn't need to share the actual data to the party. We can use some sort of identifiers to distinguish that data. And even if we want to put the data, okay, of the user data, something like this, then it should be in encrypted form. Where, okay, over here I want to introduce one term which is called homomorphic encryption. Okay, what this means is that if I'm storing something in blockchain, I'll be storing it in an encrypted form, and the other party who will be able to verify that information can also use the same encrypted data without decrypting it in order to extinguish that or distinguish that whether that information is the same or not. So that's how we can manipulate our data in order to have our solution GDPR compliant. So that's the thing. Okay, moving forward, let's talk about blockchain vulnerabilities and security basics. So I'll just be briefly covering about the security basics and the blockchain vulnerabilities that we are having. Okay, so we say that security as a process. What this means is like security is not a silver bullet. Let's say that if I tell you that if you can follow this 1, 2, 3 steps, your solution will be 100% or security proof. So it's not like this, it's a continuous process. So it's a cat and mouse fight, or it's a cat and mouse game happening between the hackers and the security providers. So it's a continuous process. We need to make sure that whatever process we are following, we are making sure we are taking enough measures in each layers for security. So we can make audits. Okay, we can have vulnerability testing, we can have routine checks, so we can have to make security as a process, not a standalone thing. Okay, now coming to the most important thing, which is confidentiality, integrity, and availability. Okay, with this CIA tried, it's the most fundamental concept of security. When we're talking about security controls or measures or anything within the security realm, it should be satisfying this three fundamental parameters. So I'll be going to briefly describe these. So with confidentiality, what I mean is that if I'm sending, let's say, some information from A to B, okay, or if I'm talking to my healthcare provider, okay, or any other my company, so that information should only be go to that recipient. Okay, no other party, or there is no middle or man in the middle attack or something happened which can manipulate that data, or somebody else can be able to get that information. Okay, so within the blockchain space, how I'm able to do this, I can have strong privacy mechanism, I can enforce strong identity access provide mechanism, IAM mechanism, in which I can make sure that I'll be giving strong passwords. My private key will not be given to somebody else, or I'm storing my private key very secretly. Then I'm using multi-factor authentication, So whatever I'm doing, just to make sure that the channel, what I'm creating with my recipient is secure. Okay, now the second part is the integrity part. So with integrity, what I mean is that if, let's say, if I'm sending you one file, that file should retain its quality or the exact values. That file should not be manipulated. So within the blockchain space or within the security space, if we're talking about, we see that we can put some nonce value, we can put some checksum in which we can identify the integrity once the copy will reach to the second party. So that's what integrity is. And then availability, you all know that if the nodes of our system are available 100% time, then we'll be able to perform the operations. So if the nodes are being subjected to any attack, so that node will not be able to perform its function. So that we need to make sure that if our blockchain network, if we are putting the nodes in the blockchain network, those nodes are 100% available. Or we should have some mechanism in which if one node goes down, the data can be reached to different nodes or can have redundancy. So that's the three parameters that we need to make sure, and in which we can also put it like encryption. If you want to use your data confidential, we can also use encryption keys, hashing algorithms. So there are lots of things in which we can have the good CIA trade within our blockchain network. Okay, defense in depth is like, we are having multiple layers of security within our network. So let's say if attacker goes or able to hack one of our nodes, and he cannot penetrate inside the whole network. So we can put security groups in between, we can put firewalls, we can put we can put ACLs, we can put different IDS or firewall in between, so that the different layers of security can be maintained and we can have a secure network. And then we talk about simple security, like we don't want to put something which is very complex, like use a hashing algorithm or something which has been already been tested, so that's, we need to make our design very simple so that we can able to control that part. Now coming to the blockchain vulnerabilities with decentralization, decentralization, if you think about a governance model, okay, in centralization network, we can be able to put some policies. We can be able to put, if our network will be, or if our data will be compromised, what sort of incident mechanism or incident management mechanism I should be complying with, or, and what sort of things I need to make sure that my data is secured. So, but within the decentralized framework, how I'll be able to do this thing? So think about it. So within the decentralized framework, we have to put it like we have to give in the same attention as what we are giving to the centralized network. Okay. Now coming to the second part, consensus mechanism. With consensus mechanism, there are some things like, if we are using proof of work, let's say, so it can subject to 51% of the attack, so there are different consensus mechanisms which are available. So if you need to make sure that you are following certain consensus mechanism in your blockchain protocol, it should be satisfying with some attacks. Like you have to make sure that those are not subjected to any attacks, and that can be also fulfill the regulatory things or the compliance things. Then smart contracts. We know that smart contracts is just a piece of code. So there are different flaws that can happen within the code. Let's say if you're not having proper auditing mechanism, we can have like buffer overflow attack. Okay, and we can have re-entrancy attack. So there are different flaws of smart contract which can be exploited. So if you are developing your smart contract, you should know that you are following proper standards and proper testing mechanism are there for your smart contract. And you can also use some sort of bug bounties or or third parties to, so that if they can exploit your smart contract, and they can tell you what are the weakness that you should be aware of. And then endpoint security with like what the users are doing, like what are the terminals. So within the blockchain space, we are giving most of the work is being done by the developers. So within the endpoint, if we can introduce some sort of security awareness sessions about the users, that how they can use their terminals, like they should be keeping up to date software patch updates, and everything should be up to date, and then it can be secured. Then when it comes to cryptographic keys, let's say, so we need to make sure that if we are using our private keys, we should not be using it in an internet wallet. It should be used in a hardware wallet. We should be saving our keys in a hardware wallet or a paper wallet, which is not connected with the internet. So there are different. So if you're talking from a security standpoint, there are different vulnerabilities within the blockchain space, and then this all is coming back to our CIA triad. That if we are not taking care of all things, our CIA triad can be compromised. So that's one thing that you need to take care of. Okay. So moving on, what are our top 5 attack vectors? What do you think? Because these are the attacks which are normally happen in the blockchain space. Like 51% attack, I have already told you about, like in which the majority of the control is now handled by the miners. So if all the miners, like 51% of the network is attacked, or they can controlling the power, so they can manipulate the data, like which can result in double spending attack. Like if I'm paying you something, okay, and my balance needs to be detected, but somehow my balance is not detected because for that transaction to be published on blockchain, it usually take 10 minutes or 15-20 seconds in some cases. Okay, but so if I'm having 51% of the attack, so since the transaction or before the transaction is updated, something can be done, or we can be able to, or with 51% of the attack, I cannot be able to send to person B. Okay, so there is something which can be happened. So how we can protect with this 51% of the attack? We should consider, like if I'm using Bitcoin or any other small protocol, let's say, the mining power should not be given to the more authority or to the major authority. So that's why how I can prevent 51% of the attack. And then they are normally, to store our money or to do that trading, we normally are using exchange. So within the exchange, so normally the attackers will feel, exchange is a good target to exploit because it's having a lot of money and there are a lot of users inside that exchange. So normally we see that we have known there is one exchange which is very popular, like Binance. So Binance using or usually are having some sort of attacks in the exchange. So what you can do in this case is that if you are using your wallet, let's say, you should not be saving the money in the exchange wallet. Why? Because exchange wallets are usually the hot wallets which are usually connected with internet. And if something goes wrong, you can be able to lose your money. Okay. So if you want to go to an exchange, make sure that they are having insurance, and where are they saving the money, or the wallets are online wallets, or the or the offline wallet. So that's okay, something that you can take care of. Okay. With phishing also, I'll give you one example also with phishing. Uh, with phishing, if let's say that if I'm getting one email and they're asking me to click one link with this, and usually this link is a flaw link or is redirecting you to a different page, So here you can take care of, you can be able to make sure that if you are receiving some sort of email from your host or from your organization in which you are, saving your money, you should making sure that you're having multi-factor authentication or proper authorization before you are putting any information. And you can also double confirm with that party that whether they have sent you that email or not. So we'll just go through to one example in the next slide for this. And there are also some malware in which they are ransomwares and miners, in which what they are doing, they are putting a script in that payload and they are injecting into your PC, and they can be attached to your root kit of your OS, and they can and they can and they can manipulate your browser to do some mining operations or something like this. So with malware also, how you can protect with this malware is that you can be able to actually keep your system up to date and make sure that if your CPU utilization is not going high, so it means that your CPU is being utilized by somebody else. So with malware, attacker or a hijacker can be able to control your network and perform some operations which can cause you trouble. And then software vulnerabilities, which is we already discussed that once you are usually or hackers use or exploit your software vulnerabilities in your code. So once you are coding or once you are developing your smart contract or any dApp, you should make sure that all the three layers of your application, which is the front end layer or the middle layer or the blockchain layer, so all these three layers are being well protected. Okay. And all the testing, all the errors are well cleared before they are launching into production. Okay. So if let's say that if you're outsourcing it or your smart contract is calling another smart contract, okay, so you have to make sure that other smart contract is following the same standards, and whether what measures they have done to avoid the buffer overflow attack, okay, or what sort of reentrancy attack they have, what sort of measures. So you have to make sure that once you are allowing your smart contract, or once you are developing or once you're deploying your smart contracts or all your software to the production, enough measures are being taken. One sample phishing attack, which I would like to show you, that see over here. If you just notice over there, okay, My Ether wallet is a popular the wallet website in which you can be able to store your Ether money, and you can also have some exchange with some tokens using this method, My Ether wallet. So with this, if you can see that here is a double, like the URL is not the same, is having some sort of static in this. So before you click on the link or before you something do like this, give proper attention to the website or to the link, that whether this link is having the right link or not. And before actually going to that, you can be able to just visit the website of the original provider. And because if there's any vulnerability, okay, or if there's any phishing attack, they usually put it on their website that, okay, now this is, or we are experiencing some sort of phishing attack. You need to make sure that no emails which are being coming from us is we will notify you. So okay, so it's better that you can be able to call that call that party in order to have good verification that whether they are the real party or not. So that's the thing. And you can see that if we go to this wallet, it looks like similar to the My Ether wallets. So, but the only difference is of over here. So with this, you can make sure that what you are putting is not, because they can keep your credentials and they can store your value also. So that's a very important thing. Okay, let's see about. Okay, we discussed about the centralization part and the decentralization part in the initial slides, but let's go a bit deep about that. So once you are deploying blockchain, you are having Okay, for instance, if you're using a private blockchain setup, you use a CA for authentication party, and this is can be outsourced to chain ID or multi-sig party. So those parties are not decentralized; they are centralized, and can similarly for like for digital wallet or for external interfaces or something like this. Once we are building our network, okay, we are having different components. Some of them are centralized and some of them are not decentralized, so that's you can think of that. Once we're talking about blockchain as a decentralized system, it's not completely decentralized. It is being made up of different or different applications, and as what you give control or how much you give attention to a centralized thing, you should be able to give the same attention to the decentralized part if you want to secure your network. So how you will be able to do this thing? You have to do some sort of analysis, like how data is flowing into your network. Okay, if let's say if you are using a blockchain, here you can see the blockchain network is actually over here. However, the nodes which is being the data is entering into the network from three channels. Okay, one is the DApp over here, and then it's a front web interface, and then it can be an exchange. So once the data or once the user is authenticated, okay, he can come back to here in this middle graph. You can see there are different nodes which are being exposed now. Okay, so here you have to make sure that you have to see, from all of these aspects, from all of these data entry points, that what sort of controls I have put inside over here and how I can detect the attacks in all these points. So that's okay, one thing you need to take care of. Okay, once we talk about the decentralized and the centralized system, you know that with centralized system, okay, we are having or we give enough importance and we give enough security measure. Let's say that okay, for the element which we need to expose to the public, we usually keep it in a public DMZ. Okay, then we put some sort of firewalls, then there are security groups, then there are endpoint security. So we are covering it or multiple layers in a centralized system. However, in a decentralized system, if we see like this, so if the network or if the participants needs to be able to come inside the network for the public network, it can come inside the network. However, if you're talking about a private network, we need a CA or authority or authorization party which can control who can comes inside the network. So once the people is coming inside the network, what they're doing or what sort of operation they can perform, we should be having some sort of IAM mechanism for that users, and also based on like whether they'll be able to perform that operation or not. And then for each the nodes, okay, so let's say the DApp or the network nodes, so we have to think about from the security standpoint that whether my network nodes are being enough having availability or not. Okay, or my network node, okay, what about if my one administrator goes down, okay, or the two parties goes down, what will happen in this case, or if my network or if I'm allowing something, it can reach the DApp and it can do some sort of cross-site scripting, or if it can inject any wrong payload, what will happen in this case? Whether I'll be having enough measures in my each layers to be able to detect the attack and take the action if needed, and also how I'll be able to respond if something goes bad. So within this network, with this layer, you have to make sure that what sort of attention you are giving to a centralized system, you should be able to give the same attention to the decentralized system as well. Okay, so one approach that we usually do in order to actually understand the attack is to do the threat modeling. With threat modeling, it's actually a systematic approach in which once we design our network, we check each layers and make sure that what attacks can go into each layer. I'll just show you one example. Okay, so if we have seen this previous slide, I have shown you some sort of so here what you notice is that there are different sort of attacks that can happen in each layer. So that only I can be able to know once I'll be able to draw my architecture and see the data entry points. Okay, I'll give you one example just to understand better. Okay, let's say that if you are having your main house and there is only one gate. Okay, with comparison to a house which has having multiple gates. Okay, so in that case, so think about it. House with only one gate is having the less chance of an attack. Why? Because he's having only one data point, right? In case of a system which is having multiple points, we have to put multiple controls on each layer, and we can be able to understand that, okay, if gate 1, if the attack happened on gate 1, how I'll be able to detect that, whether I have okay, any alarm, any metrics which goes down, or what sort of controls, whether I'm okay, whether I'm using fences or using guard dogs or anything, you know. So I have to understand all my data points, and then I have to put controls, and also within the controls I can be able to understand that what sort of attacks that can happen from each layer. So here we can know that, okay, for the spoofing, which can, okay, which is falsifying identity. Okay, so if I'm claiming to be a person which I'm not, you know, so that can happen if my IP address is compromised, you know. So we have to make sure that I'm having enough, or if I'm having packet filtration mechanism in which I'm seeing all the IPs, and if there is more requests coming from my, okay, from one IP, I should have an ACL or an access control mechanism in order to block that particular IP, you know. So that's how I can prevent spoofing attack. Then once spoofing is happened, let's say that if your attack is, or if the attack is successful and the spoofing attack has happened, then if the data is disclosed, how I'll be able to protect, or how I'll be able to actually communicate this thing. So we need to have some sort of data officer in your organization who, in case if there's a personal data involved, they can be able to communicate to the government or any law authority that this data is compromised. Because what happened with that data, usually when data is compromised, they put this data into the dark web, in which they do some trading and something like this, you know. So if your data has been compromised, you should be able to communicate to the world that, okay, this data is now compromised, so that if something bad happens with that data, you'll not be able to prosecute for this. Okay. Then for the DAP part, if let's say if there's non-repudiation utilization, you know, how you will protect non-repudiation. With non-repudiation, what I mean is that I can be able to catch the person who has made the mistakes, or I can trace the person and he cannot say that I'm not that person, you know. So that's what reputation is. So how I'll be able to make sure that I can be able to do some good accountability or catch the person, or make sure that he's the right person, if I can use digital signatures or certificates, you know, for this. And for any flow that has been happening within this network, all the data processing, all the data transaction that has been happening, if I have to make sure that they are using TLS, if I'm using web browser, they should having, you know, encryption protocol mechanism in which what data is traveling is in encrypted form. And also I'm using non-cookies, you know. So so, so once you will be able to draw the architecture, then you will understand it better. Okay, there's one thing, how you will prevent denial of service attack. Because if something happened, the attacker can do some spamming, or run some packet query into that system, and that system will not be able to respond, and that system will be off, you know. So if we are having multiple systems, which let's say if one system goes down, then this system needs to be isolated from the network, you know. So that's how I can be able to prevent denial of service attack. Okay, so once you have identified all the attacks, then you have to put it like, you know, what sort of classification you need to do for this. Let's say that with spoofing, it can result in some identity theft, you know, it can result in data loss. So this practice is good, like, you know, once you identify all the attack vectors, then see that what is the result of each attack, which will help you to deduce the monetary value associated with each attack. And once you will be able to see that, okay, if I'm having denial of service attack, if my two nodes were not working or went off, then I'll be able to have a loss of, let's say, 10,000 reals. Okay, because that nodes which are processing the information is processing the data worth of 10,000 reals. Okay, so in case of that loss, I'll be able to not save that money. So I'll be putting the control which can be able to satisfy that thing, or I'll make sure that other nodes are available in case of one node goes down. So with this, I can be able to do a lot of good things within my network. Okay, so coming back to blockchain security domains, once in I can put it like a security domains in which
it's, I think. Am I audible to everyone? I think I'm getting a notification that I need to unmute my speaker. So I think it's okay. I can see my voice. I can hear my voice. Okay. So let's classify or put all the attacks into, within the blockchain security domain. So we have identified that with these attacks, we can be able to classify or put 4 domains, which is one is a platform domain here where blockchain is deployed, and here what I need to make sure that the data is synchronized within the each node and it's having consistent one. And with the front end or with the front end server application, uh, how I'll be able to make sure that all the top 5 attacks are mitigated. So that's how once I'll be able to do this classification, I can be able to put different checkpoints. Like, okay, for endpoints, I'll take the measures of giving security training to my administrator. I can be able to put, like, how to prevent spoofing attack, and how I'll prevent data disclosure. So a lot of things I can do if I am able to classify and divide my security domains into each aspect, and I can be able to put different controls in each domain. Yeah. Okay, just to summing it up, because I'm getting one. Just hold on for 1 minute. I think there's something wrong. Okay, now I think it's better. Okay, so how I'll secure my deployment process? What steps should I do? Because we all need to secure our network. So the first thing is acquire blockchain expertise. Okay, with blockchain expertise, what I mean is that you don't need to, or I'm not saying a developer or something like this. I'm saying a person, a security officer who understands blockchain well and who understands security well as well. Because he'll he he will be able to develop a governance framework, like the policy and everything, and you have to sit and you have to do this from day one. Okay, you should not be saying that, okay, once I'll be developing my MVP, then I can be able to hire the resources for that. So you have to think about security as job zero. Then what sort of security goals that you need to keep, or whether you will be able to have more secure or the confidential part, or whether you will be able to have more attention for the integrity part. So what sort of things you need to keep in your mind, what sort of accounting standards, what sort of accountability metrics you need to keep. So you need to put your goals upfront once you acquire that blockchain expertise, and then configure blockchain. Like, what sort of, if I'm using public blockchain, I need to make sure that my mobile phone or my end node, which is using the client, okay, this node is being constantly updated with patches. He's using the latest OS. He has no vulnerabilities. He can be able to, so within case of private blockchain, what sort of consensus mechanism you're using, so you have to make sure that once you're configuring the blockchain, you have to think from the security standpoint also, that, like, how I'll be able to secure each part of my node. Then perform risk assessment. The best I think of performing a risk assessment is to first classify the risk. Like, write down the risk that if, let's say, if your administrator goes from your organization, or if your all nodes become unavailable, or if, let's say, if your data is compromised. So once you have write these things, quantify it, okay, with respect to priority, like whether it is a high risk, low risk, or what. And within that prioritization, you can also think about, okay, actually quantifying it, like putting a number, once this risk is realized, what sort of loss I can have it. So once you will have all those points in your risk assessment, then you can be able to put measure, like, I need to have a firewall in my public subnet, for my public subnet. Okay, like, I will be having 3 CS for my network. Okay, why? Because if my administrator goes somewhere else, or if my administrator node is compromised, then I cannot afford my data to be lost. So there are different things. Then just hold on for 1 minute. Yeah. Okay. So with security controls, I can be able to put security governance, like, whether I'm having disaster recovery plan or not, or whether I'm having business continuity plan. If my one region goes down, what sort of things I have, whether I'm having enough backup of my data. Okay. If let's say if I have to choose a security vendor, okay, what sort of options I have, or whether those security vendors are having some sort of compliance mechanism, or what sort of controls they are having. So we have to put all the things together, even from the software development cycle, that once you are developing the software, are you following all the steps of software development cycle, like the validation or the testing or the deployment strategy. So there are different pieces which comes if you need to deploy a secure blockchain network. Okay, here I'll just show you a demo of one of my solution. Actually, this solution I have developed, and it's for the Saudi market specifically. And here I'll make sure, once you will be able to see this video, I'll just give you a brief intro or a brief architecture view, that how I developed a good security mechanism for the solution. So if you just can be able to see this video, then I'll be able to tell. Yeah, please. Okay, so I'll just stop here. You can see the video in my YouTube channel. It's okay. But I just need to show you from the security standpoint what major. So if, let's say, if you're developing a security blockchain or a blockchain solution for a payment application or any solution, okay, within the blockchain space, first, once you are developing an architecture, then see that I'll just show you. Just hold on a minute. Yeah, I'll just show you this architecture diagram. Yeah, see this one. Once you will be able to store any information, let's say if there is a consumer or somebody wants to purchase something, so see that how that information, what you're going to store of your consumer or your merchant, will be able to process, or where you will be storing that information. If you're storing your personal information of anyone, make sure that you are using the SSI wallet, which is a self-sovereign identity wallet. So with this wallet, I'm not giving the actual information to the bank or any third party. I'm giving just identifiers of that information, like a transaction hash or something. So with that information, if they want to check or verify it, they can do this on a blockchain network by not actually seeing the information, by using identifier. And that identifier, I have put it by matching all the criterias which needs to be fulfilled if I need to have a good KYC. So that's how I can do this. And if I'm using a payment solution or something like this, once you are doing a payment or any transaction, make sure that the node or the system which is handling that transaction is not storing the information. Okay, he's just, if he needs to store it, he can be able to store it within like encryption or using some sort of zero knowledge proof. Okay, and for this, if your information is going towards bank or any network, okay, this information is using some sort of encryption protocol or some sort of encryption, and with encryption protocol it should be using a maximum key length, let's say 256 key length. Or you have to see that for sort of encryption using what you're using is not being compromised anywhere. So that's how you can maintain security. And once you will be able to do this thing, then you will be able to actually get the license and be able to get a node or node from your regulatory for your solution. Okay, so if you want to know Okay, so if you want to know more about it, you can reach out to me for this. Okay, so here just to close, okay, what sort of recommendations that should we be having for the phishing and social engineering attack? Make sure that if you are getting any email, because now in the COVID times we are having emails and we are having different sort of things. So don't click any link and don't reveal your passwords to anyone and even to your peers. And if you are using some sort of crypto wallets, your private keys needs to be stored on the hard wallet. Uh, okay, for the exchange, you should not be saving your money to the exchange in the exchange. And once you're developing your softwares, it should be complying all the regulatory standards and all the software testing standards. And one thing I need to highlight over here, like most solutions like blockchain or any AI solution or any solution are using the cloud solution deployment. So make sure that you are choosing the right region, because some authority don't allow you to transfer your data outside Saudi Arabia or outside one particular jurisdiction. So make sure that the region of your cloud provider lies in your inside your jurisdiction, and how they are controlling it. Okay, let's say I know Amazon Web Services. Okay, they are using, or they are doing a wonderful job, and they are having different some sort of. And once you are using cloud, make sure that you are having a dedicated tenant model in which your rack is only your rack, okay, in the cloud service. That rack should not be used by anywhere else. Okay, that's how you can comply with licensing thing. So that's two. And third thing is that how they are storing your keys. Are they using a dedicated security module for storing your keys? Okay, so that's the thing that you need to take care of. So thank you all. I would like to thank Monshaat and Ms. Alanaud for giving me this opportunity. And if you want to reach out to me, you can reach out to me on LinkedIn or on my YouTube channel or in Twitter. So if you have any questions, please ask me. Yes, please. I think if you have your question, you can put it in the Q&A and we can take your questions if there are any. Let me check the chat window. Yes, I can see one question over here. Yeah, there is one question asked by Naneem that if I'm using, let's say, enterprise blockchain solution, security of consensus mechanism is a major concern or not. See, Naneem, if you are using enterprise blockchain solution, from the security standpoint, you have to deal this with the same way as you are dealing with a normal enterprise organization. Because we should be we need to make sure that we are having enough controls on each layer of our data flow, and also we need to have some mitigation strategies if something goes wrong. So that's one thing, because see, enterprise blockchain is just like a normal enterprise thing in which you're having any solution. Okay, so if you want to use consensus mechanism, for instance, in this case, make sure that you are using pluggable consensus mechanism and you are having some sort of rotation of duty policy. Let's say that if you're having 2 validators now, okay, so make sure that after 2 months those validators can be changed and you can put some different validators so that they cannot control the network, okay, and they cannot do some monopoly for this. So just think about making sure that you're giving enough attention as what you give to a centralized enterprise organization. Yeah, I hope it makes sense. Are there any more questions, please? Okay, I think there are no more questions. If you want to reach out to me, you can reach out to me on LinkedIn or my YouTube channel. I'll be happy to answer you and clear your thoughts. Thank you, Monshaat, and thank you all of you for being there. I hope you enjoyed the session. Thank you very much.